Hello everybody, today we're going to look at the percentage error of an approximation. So that's when I approximate what the value of something is, and then I actually find out the exact value and I want to compare. This is why we do it and how we do it. So percentage error from an approximation, we're going to start off by looking at a hypothetical potato. If I think of a potato and I'm going to try to estimate the weight of a particular potato and it looks like a pretty regular potato, I'm going to say, you know what? There's about 5 potatoes in a kilogram, so this was one potato. I'm going to say it's approximately 200 grams. So that's going to be my approximated value of 200 grams. Now, turns out that I find a scale and I put my potato on top of the scale and I read and it's actually 179 grams. So I was a little bit over. And therefore I have the exact value of the weight of the potato, which is 179 grams. And I write it like this for value exact, 179 grams. Okay, let's start over again with a different thing. I'm going to start over with a clove of garlic. Now I try to estimate the weight of a clove of garlic, which is very small, very difficult to have an actual reference. So I'm going to say it's approximately, I don't know, like 5 grams. Why not? Looks pretty small. Approximate value of 5 grams. I do the same thing. I put it on top of my scale and I get, oh well, it's actually 2 grams. So I was actually well over it. So the clove exactly weighs 2 grams. Perfect, no problem. And I write it down like this. The exact value is 2 grams. Now notice VE for exact value and VA for approximate value. Let's suppose now I want to answer a very simple question. Which one of the two was a better approximation? My approximation for the potato or my approximation for the garlic? Which one was I better at doing? Here's a simple way to think about the problem. Now, this is how you should not measure the quality of an approximation. Here's what I got for my potato, my approximated value, and my exact value. I could just say, well, the difference is 21 grams. That's how far I was. And if I think about the clove, the difference is going to be 3 grams, right? I could think of it this way. And if I think of it this way, somebody might say, well, you were much closer with a clove of garlic because you were only 3 grams away, and much further with the potato because you were 21 grams away. Is that really true? Was the approximation of the weight of the clove better? Actually, it was not. Because if you think about it, the approximation 5 grams is more than twice the actual weight of the clove. That's not the case with the potato. The potato was actually quite close in relative terms. And that's very important. The idea that we figure out how close we were relative to the actual weight of the potato. So this is how you actually do it. This is the proper way to do it. You have a formula in your formula booklet, and it looks like this. The percentage error is designated by this funny Greek letter. It's called epsilon, okay? And we use that letter to represent error. So the error is going to be done by taking the approximate value, subtracting the exact value, dividing that result by the exact value, doing the absolute value of what you get, and multiplying times 100. And the units are just going to be percentage. Now, it's good to know that in your formula booklet you have VE to show you what exact value is and VA for the approximate value, so you have the little reminder here. Let's go back to our potato. If I'm going to use the formula now, this is what I would get. Percentage error is 200 grams, my approximate value, minus 179, divided all of it by 179 absolute value bars times 100. And if I just put that in my calculator straight away, I'm going to get 11.73. 11.73%. That's my percentage error. If I do the same thing for my approximation with a clove of garlic, I'm going to get 5 grams minus 2 grams over 2 grams, absolute value of that, times 100, and the result is going to be 150%. Now here is very clear that the error here is more percentage-wise. In relative terms, it was much closer. My approximation for the potato was much closer to the actual value than my approximation for the clove of garlic. This is a very simple formula to use. I want you to understand where it comes from and what the logic behind it is and what the advantage that it provides us to be able to compare different approximations and determine which one is better. That is why we use this formula, and it's very simple to use it once you know it's the right time to use it. If you have any questions about how to put this in your calculator, including the absolute values, do by all means let me know. Thank you very much for watching. Goodbye.